Okay. 638 shopping offers. In Leetcode store, there are some kinds of items to sell. Each item has a price. However, there are some special offers, and a special offer consists of one or more different kind of items with a sales price. You're given each item's price, a set of special offers, and the number we need to buy for each item. The job is to output the lowest price you have to pay for exactly certain items that's given, where you can make optimal use of the special offers. Each special offer is represented in the following way. The last number represents the price you need to pay for this special offer. Other numbers represents how many specific items you could get if you buy this offer. You could use any of special offers as many times as you want. Okay, I just read a lot of things. I don't know if I understand it, but let's see. The two kind of items, A and B, their price are $2 and $5 respectively. Okay. In special offer 1, you could pay $5 for 3A and 0B. In special offer 2, you could get $10 for 1A and 2B, and then you combine them to you need to buy 3A and 2B, so $10 for 1A and 2B. And then 4 for 2A. Do I have to buy them exactly? Or oh, exactly. Okay. And these are just more examples. Notes there are at most 6 kind of items, 100 special offers. For each item, you need to buy at most 6 of them. You're not allowed to buy more items than you want, even if that would lower the overall price. Okay. Yeah, I mean, I guess this is just another dynamic program problem. I think kind of the tricky thing is that the tricky thing is just, I mean, there's a lot of words. I think the thing that you may recognize quickly is that this is essentially like a knapsacky type problem. So it's always going to be NP complete, which means there's some way to do it in a dynamic programming way, and that's where watching the constraints really matters. I don't know if I like this one interview question, but basically the special trick here is noting that there are at most 6 kind of items for 100 special offers, right? And for each item, you need to buy at most 6 of them. So the state in that case, right, is just 6 times 6, or roughly 6 times 6, but 7 times 6 because you could count as 0. So that's the number of maximal states, which is just 42 values, and then you could linear go through all of them. And I think that's essentially what I'm going to do. So in this case, you just have, so your state is the number of kinds of items and the best price at that item. So you can imagine something like 2.5, then that means so that, and you do recursion on the special offers, and 2.5 goes to 1.4 or something like that, depending on the prices, and okay. I think I'm going to just do that. The input is kind of like funky. Maybe it's always be funky because it's not, the special is not really an object. So like you put in the last value. Okay, fine. But special concept. Special concept. Guess isn't that just okay? Okay. I mean, I think that's mostly how I'm gonna do. I'm actually just gonna be lazy and say interview. And I'm just going to create a very lazy 6-dimensional array because that's just what we need. The for loop is going to be crazy for it. Yeah. Let me just use map set. Oh no, how did I get rid of this? Oh, oops. Okay. Yeah. The lowest price, so usually for that I like to set infinity, that's something high. Doesn't really tell you what the maximal cost stuff is. So let's just say million. I don't know, maybe that'll get me wrong. Yeah. Oh. Can I do this cleaner? Okay, fine. I would say there's an interview question. I don't know if I like this that much, to be honest. But maybe I'm just a little sick of dynamic programming problems today. So maybe it's not so bad. But it's, it's a knapsack problem. So it's always going to be a little tricky to, it's always going to be like the same-ish, like couple of ways you can solve it. So yeah, I don't know. Maybe it's okay. Maybe I could have done this a little quicker, but okay. Yeah, okay, maybe I'll use. It's just thankless code at this point, so I'm just trying to get through it. Okay. So go. It's just saying my globals. Real quick, I don't have this one. Okay. Okay, I mean, that's no needs. Now these are just the price list, so that's actually even really matter. Specials done also in a weird way. This can only have 100 offers. Okay. And then the needs. Okay. well, that's just going to be the input. That's fine. Yeah. Definitely not proud of this code, by the way. Also, it shadows. I even need this. Yeah, okay, fine. And I need something like this, but I don't need this. Each size should be the same as price size, I guess. Okay, so using my prices, so I could just do something like get best. I think also if I had been a little smart about it, I would have converted this into this is very hard code, as you know, based on the input. But if I was a little smarter about it, I would just do some mathy thing that just recodes this into a number that is more useful. But it'll be okay for now, I guess. Okay. Yeah. I didn't pause the. Cost of the offer is just equal to offer size. So I think it's a little unfortunate how they do it, but it's fine. Okay, so now we just go through all the offers. Yeah. Okay, clear item. Clear. And take this. Actually, and now I'm just going to return just to see what kind of compiles first, one step. Voice. Okay. That was supposed to be in space. Oh, no, that should be right. Office is special. And maybe there's just enough pointers. Really? Not gonna lie, of all the things that I was expecting, I don't know that I expect this particular one. Maybe we should use the Python or something. Oh, dumbass. I just didn't actually define the max offer, so it didn't space. You know, fine in the middle of a dot or something. Okay, so that seems okay. Okay, now I can do it. Just don't leave them muck around here. Need more base cases. We should have done some ways to. We should have done a smarter way to handle state. Nope. I think in theory this works better with less than 6 states, but caught myself in the hole a little bit here. Okay, this is mostly right. I think the things I can do to exploit. I mean, there are different ways to handle basic state, but I'm just gonna do the thing where, yeah. So, because there isn't an impossible case, you can always use the price list to kind of generate it. So I'm just gonna do something like, actually, the best is to price. Yeah. Yeah. Also items. So that should not have changed the answer, but at least it saves the state. Okay, so expected is 14. How did we get 4? Makes sense. Take stuff up. Numbers. This should allow us. This should be infinity in this case. Okay, so that's true. So maybe there's a typo, which is very possible. These multi-dimension dynamic programming problems. It's always a little. I mean, looking back, if I were to do it again, I would probably have an encode state function just to kind of help me out. But I mean, makes sense. Yeah, with just 2 left. I'm confused. No, we need 3 and 2. Okay. So 3 and 2, the max is 16, which is already a little high. Oh, that's the base max, which is great. How do we 4? 2 and 0 would cost 4. But, because I don't. Plus, okay. So typo aside, actually, let's try the second example. I think people. We'll make sure that input and output matches. I don't know how it pauses it. Okay, wow, so it was just that I was putting input in a weird way. Okay, yeah, I mean, I think I'm pretty reasonably happy with this, and I think in theory, there are definitely potentials for edge cases, but roughly, what? No, okay. Actually, it seems like this is the one case where I handle things better than the default thing does, but depends on the judge. Okay, well. Now I'm just taking test cases. I'm just testing a few edge cases. I don't think there are that many edge cases other than like the empty cases and stuff like that. And there you go. That was probably more tiring than I would have expected. I think in general, like I said, if I were to do it again, I would have an encode state kind of thing to kind of combine this 6-dimensional state into one number, like a base 7 number, if you will, like we did earlier, or something like that. That would make a lot of the typing easier, but otherwise this was a pretty straightforward diagram programming problem or memorization problem in the way I did it. Yeah. Okay. I mean, it's a standard knapsack problem, so there are enough